Hello good day viewers. In this tutorial we want to find z modulus given the equation iz to the power of 3 minus z plus z squared plus I equal to 0. First of all, we are going to solve for z in this equation before taking the modulus. So let's get started. So here is the equation. We are going to factorize it in batches, the first two and the second two. The first two, we have only z in common, so let's factor it out. We have z here. Inside we have iz squared, right? Then minus 1, because z is already out. Then from this second two, we have only 1 in common. So we say plus 1 multiplied by z squared plus what? I. The whole of this equal to 0. We wanted these factors to be exactly the same, but since they are different, don't worry. We know that in the complex world, -1 is the same thing as I squared, right? Remember that I squared is equal to -1. So we are going to substitute that -1 with I squared. Therefore, our factors becomes z multiplied by I z squared, then plus what? I squared, plus 1 multiplied by z squared plus I. The whole of this equal to 0. Now we have I here, we can bring 1 out. So we have I outside, already we have our z. Inside we have z squared plus I, because 1I is out already. We have plus 1 multiplied by what? Z squared plus I. The whole of this equal to 0. Now we can factorize it because we have z squared plus I in common. Therefore, we have our factors to be iz plus 1, then multiplied by what? Z squared plus I. The whole of this equal to 0. This implies that either the first or the second factor will be 0, right? So we have iz plus 1 equal to 0, or the other one, z squared plus I equal to 0. Now let us solve for z in these two equations separately. From the first one, if we take 1 to the right hand side, it is going to become negative. So we have z equal to -1, but we know that -1 is the same thing as I squared. So we have iz equal to I squared. Divide both sides by I. We have z equal to I. This is the first solution. But remember, we are looking for the modulus. We are not done yet. We want to find the z first. Then from the second one, we have z squared to be equal to what? -I. If you take the square root of both sides, you have z equal to plus or minus the square root of -I. And square root of -I is the same thing as -I to the power of 1 over 2, right? Z equal to plus or minus -I to the power of 1 over 2. Now let us evaluate this -I to the power of 1 over 2 applying the Moivre's theorem. Remember that if you have, let me use another color. Remember that if you have z to the n power, according to the Moivre's theorem, it is the same thing as r to the power of n multiplied by cosine of n multiplied by theta plus I sine of n multiplied by theta. So all we need to find is r and theta here, because we have our -I to the power of 1 over 2, which is the same thing, where z is equal to -I and n is 1 over 2. This is equal to what is radius, is just the absolute value of the coefficient of I. The coefficient of I is -1, the absolute value will be 1. So we have 1 to the power of what? 1 over 2 here. Then you multiply it by cosine of what? N is already 1 over 2. But what about the angle? To find that angle, because we are looking for I negative, it is going to be on this leg, which is just what? I think this is 3 pi over 2. So our angle is 3 pi divided by 2. We have 3 pi divided by 2. I can multiply them directly, right? So we have 3 pi divided by 4. So this is 3 pi divided by 4 plus I sine of what? 3 pi divided by 4. 1 to the power of 1 over 2 is the same thing as 1, so it doesn't matter. But what is cosine of 3 pi divided by 4 is equal to negative root 2 divided by 2. So this is negative root 2 divided by 2 plus I sine of 3 pi divided by 4 is what? Positive root 2 divided by 2. And this is just what? Square root of negative I. But because we have plus or minus, remember, you have to attach plus or minus here. And hence we say that our z is equal to plus or minus negative root 2 over 2 plus positive root 2 over 2i. This is our z. But remember, we are looking for z modulus. Z modulus, remember, it is equal to the square root of what? A squared plus what? B squared. For which A is the real part and B is the imaginary part. So let's start with the first solution. The first solution, we obtain what? Z is equal to I. So if you have Z equal to I, it is the same thing as what? 0 plus I, for which the real part is 0. So if you substitute everything here, A is 0, B is the coefficient of I. We have Z modulus to be equal to the square root of 0 squared plus 1 squared. 0 squared is 0, 1 squared is 1, 0 plus 1 is 1, square root of 1 is 1. Therefore, we have our Z modulus to be equal to 1. What about the second one, where we have this? Since we are taking the absolute value, remember this is going to become positive. Therefore, we are going to consider only negative root 2 over 2 plus root 2 divided by 2. So the second absolute value will be equal to the square root of what? Negative root 2 divided by 2 all squared plus positive root 2 divided by 2 all squared. Remember, the b is just the coefficient of I. So if you simplify this, you're going to obtain 2 divided by 4 plus 2 divided by 4 under square root. 2 divided by 4 plus 2 divided by 4 is equal to 1. So you have square root of 1. And square root of 1 is equal to 1. Therefore, Z modulus is equal to 1. So in both cases, the absolute value is equal to 1. And this is all I have for you today. Thank you for watching. Do share to your learning colleagues. And don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.